All right, we should have an understanding right away. This is exponential function because the exponent is a variable. Secondly, this function is growth, right? Because the exponential function is that of a number bigger than 1. So if it's growth, it should look like this. And it has a horizontal or vertical. It's not happening to the x, right? That would be horizontal. It's happening to the whole function. So therefore it's a vertical stretch. So they're taking this and they're stretching it. So therefore it's going to go even further. It's going to go up faster. That's all. Okay? In fact, it's going to go up 2 times faster. Because it's 2 times. Come on, people. It's like basic math. Alright? So, we're going to take this function, we're going to plug in some numbers so we know how to graph it. That's it. We already know what it looks like. So, let's figure out what happens. What's the easiest number to plug in? Huh? 0. So you got x, you have y. I'm going to plug in a 0 for x. Because if I plug in a 0, that turns this into a 1. What's 1 times 2? Bam. What's 0 and 2? 0 and 1, 2. So that's where it's crossing.
I hate math. Math can just...
Okay. Then, we're going to plug in some easier numbers. What's another easy number? 1, right? 1's easy. Okay. So that's going to be, what, 3 to the 1 power. What's 3 to the 1 power? 3. What's 3 times 2? 6. So this is going to be 6. So it's going to be 1, but then 1, 2, 3, 4, 5, 6. Oh, snap. Look, it's going up really fast, just like we thought. Okay? Now, let's plug in another easy number, but on this side of the graph, because remember, this should look like that. Right? So, how about a negative 1? What is 3 to the negative 1? A third. Very good. So, 1/3 times 2? 2/3, right? And so, at negative 1, we're at 2/3. So that means we're right here. Okay? And it looks like we're going to go really close to 0, but never touch it. Right? And that's it. That's graphing. That was pretty easy. Exponential graphs. Now, do you remember what it means to do an inverse? What's an inverse mean? The y becomes x, and the x becomes y. What? That's it. That's all it is. Inverses. The y becomes x, and the x becomes y. And then you resolve it. You solve it for y. So how can I resolve this for y? How do I get y to be outside of the exponent? When you have a variable as an exponent, what do? When you have a variable as an exponent, what do? Come on, people. Logarithms. Right? You should look at this and go, logarithms. Because it's in that form. It's in that exponential form. If I want to solve for something in an exponent, I want to use logs. Okay? So, log. What's my base? What's the base? 6. Okay? Alright, log base 6. What's my exponent? Y over 5, right? And then what's my number? No, it used to say y equals.
Oh.
Right? Then we switched them, right? X and y. Y became x and x became y, and that's the whole reason why we got to use this. Okay? So, now what's my exponent? Y over 5, right? But what's my number? Remember, there's a number, and there's a base to the exponent, right? So the exponent, right, is equal to the log of the base. So we're just going to go base 6, right, of the number x. Okay? And then we got to solve for y. How do we solve for y? Multiply by 5. So y is equal to 5 log base 6 of x. Not that hard. Okay? It's all logarithms. You can do this. I highly